Hello, Java community. This is Vinicius Senger, direct from Ubatuba, Brazil, one of the most beautiful city in this country. And today we are going to visit my lab, my space that I'm very lucky to have this space with different tools available, different components, and it's my kind of playground. And I'm going to show you a little bit more about them today. The idea is to talk about some projects that I did in the past, uh, talk about some experience that I had using different types of boards and migrating projects from Arduino to Raspberry Pi. And I'm going to show about I'm going to show a little bit my space and my tools, my CNC machine. So let's start having fun. This is the place that I have all the resistors and all the types of components that I need. I have some boxes, many plastic boxes when you start doing working with embedded and do it yourself, you start buying a huge amount of plastic box. And I have different projects. Here on top I have my computer, old computer collection. It's a Z8 computer. And so here I have more tools that I use and some projects that I put here today to show you. I have some cool projects like this robot Steve that we did for Maker Faire. We have this very nice panel with Raspberry Pi, and this UDO board is very new. It's 4 times more powerful than a Raspberry Pi. It's a huge amount of a CPU and GPU acceleration. Is very nice board. And here we have the famous embedded panel that we use to explain different types of boards that people can use this panel during some hackathons or workshop that we use to promote with Oracle. So here I have some basic tools to cut things like a jigsaw. Here you can just turn on and cut your material like wood or plastic to build your own prototype. So I start with this machine to cut my robots, and the finish was not that good, but the quality is not that good. But you can make many cool stuff. You just print the draw that you want to cut, you just glue in your wood and follow the path using your hand. So it's kind of a CNC manual. And here is to make hole. This is very nice one, very good to have. And I have here my Lego. We showed the Lego demonstration. Is a Linux, is the EV3. That's a cool project. And to finish, I have here my own stock of components, Raspberry Pis and relay boards and everything. And now I'm going to walk in my house. I'm using one room just for electronics, soldering, software development, and I don't usually do the dirt part of the work, like when I cut these panels and I'm going to produce, and I make a lot of dirt. So I go to another place in my house downstairs, and um, here is the place that I have my own CNC machine. This is very nice. It's a medium size of CNC machine. We use to cut wood. I like to work with wood. This is a prototype of Steve's head, the first one, and we can make very cool stuff like cutting and graving and engraving and so we use stamps to make our finish. And this is a pretty cool machine, very nice. I love to be working here. As you can see, I have all the wood pieces that I already cutted here, and so I can use it to make some fire. And so such a lucky thing to have a CNC machine in your house, because you can produce different types of prototypes with very good quality for a do-it-yourself project. And I'm going to start showing something with Raspberry Pi, Java, and a lot of do-it-yourself spirit. That is this Raspberry Pi camera. This is a camera that I did by myself. So I have here, the top is acrylic, but inside you see that I'm using plywood, very thin plywood. It's 3 millimeters plywood, and the plywood is very good for do-it-yourself because the screws can go very strong, and you can make even in this size of plywood, I can make holes and without breaking the wood internally, and very strong holes for the screws. So it's very nice, and the camera stayed right here. And here we have the SD card, and here you can use the GPIO cable here if you need to put some sensor. We have the video composite and the audio, and here we have the HDMI connection. So I use to measure, and I make the cutting plan in using a software, and so everything can fit very well inside, and you can protect. And I love you wood, but you can put stamps, and it will be very acceptable quality for a do-it-yourself project. And so here we just have one button. The idea of this camera is to take out pictures every amount of minutes. Like so, this is a cool project that I am producing to a friend. So I'm working on this project, and using Raspberry Pi, Java embedded, and DS Java SE, and I'm using Pi4J to trigger the camera. The camera, we don't have a Java API for using the Raspberry Pi camera, but you can call a command line using Java, very easy, and call the Raspi Stew command line to take pictures. And if you want to reproduce this nice camera, do it yourself, Wi-Fi Raspberry Pi camera, you have all the source code available in the java.net/challenge. Just go to the challenge, IoT Developer Challenge website, and you can download the Pi Camera project. And I talked about this project in the video lesson number 4 about Pi4J and GPIO. You can also watch this video on YouTube in Portuguese and in English. So next project that I'm going to show you is a project where I started to change. You know that 3 years ago we didn't have all this amount of variety of boards like Pseudo, Raspberry Pi, BeagleBone, Black, Mino board, Intel, Galileo, the Udo board, the RIOT, and many other boards. We have a huge amount of options to run Linux inside a single board computer that will not consume a lot of power energy like Raspberry Pi. It's actually much more than a microcontroller, but it's not bad. You can run Raspberry Pi on battery. I tried an experiment here in Ubatuba during the summer. I was with a solar panel like the size of a 15-inch 15-inch laptop, the solar panel was, and I could power on. I just plugged the solar panel in a voltage regulator because the solar panel can give you like a 25 volts, and I put in a voltage regulator to 5 volts and plug the 5 volts regulator into the Raspberry Pi, and so no batteries in the middle, and the Raspberry Pi could stay alive hours under the sun, so it was awesome. And but here in the past we didn't have this amount of options of boards. Actually, we have much more things like Arduino stuff, and the Linux on single board computers was not very popular. So I started doing the J-Home automation project, which we won the Duke's Choice Award in 2011, so 3 years ago. And at that time, I was making a Java EE gateway for house. So I was using EJPs to control relays and schedule appliance in our houses. Like every 10 a.m. you turn off the light or something like this. And everybody thought that oh, you are crazy to use Java EE for doing that. And today we have inside the single board computers the capability to run a Java EE container very easy. Like if you want to run Jetty or you want to run Tomcat, you can run, and you have the Java embedded switch, which is a very nice Oracle stack of products to have a very lightweight Java EE container running with good performance on Raspberry Pi. But this project I used to produce this hardware with Arduino based and relays and LED control and sensors like temperature, humidity, light sensor. And I used to integrate with Java EE, so I have this in my background in the past. And one experience that I had with Arduino, bad experience, it was driving relays with Arduino. It's very basic stuff. But if you have some types of appliances like fans, when you stop, it generates a type of current, a noise that just locks the microcontroller, the 8 mega microcontroller. Sure, you can isolate, like using optical isolation, or you can put some filter between the appliance and your relay, but it's very inconvenient to do that always. And actually, it makes the project more complex. So this is the first time that I was in a really bad situation. I was in Devox, and my demos was crashing all the time because Arduino was freezing all the time. That I tried to control a certain type of lamp that generate a noise and lock the 8 mega. So fortunately, the Raspberry Pi, we can drive the relays in a very nice way, used by 4J, and Raspberry Pi, it doesn't have the sensibility. You can use regular relays without optical isolation. So this is such a practical stuff that we just learn by doing, and it's kind of situations that I am collecting in my last 6 years with Arduino, that are reasons why sometimes you must use something more robust than Arduino, using Java, and we using operational system, and these boards, they are very more easy going with different types of currents. And so this project, I am happy to do the J-Home automation project, because now we have many options for doing home automation. J-Home project is just part of a history, you know. And now I'm going to show, let me think here, robots. So here I have this cool spider. This spider, I have Raspberry Pi and a control board to drive the motors, and I like to I like to try to use boards like more than blinking on LED. So the first thing that I like to do when I just buy a new board or receive a board sample, I like to put the board to drive a robot and see what is happening and how does it perform, how will be the connections, the power supply for the board and for the robot. So it's very nice to do robot because you have many different challenges, including some types of boards can be sensible with DC current also, and sometimes you can generate noises with the motors in your wireless connection, like radio frequency can be affected by that. So it's kind of stuff that is very nice to try to make a robot because you learn a lot about that board. I did many robots just using Arduino, and when I started with Raspberry Pi, I just add the Raspberry Pi as the internet interface to the robot. So I can have the Raspberry Pi talking with my old Arduino project and using the serial communication. And I could make a gateway to the robot, so I can command the robot using RESTful APIs, and I just starting doing this gateway that you should talk that can talk with any serial device. So you can use your Raspberry Pi, any serial device connected through the USB, and we can expose any serial device using Java embedded server REST to the TCP/IP world. So it's very nice way to integrate things that are not TCP/IP with the TCP/IP world, like infrared components. If you have air conditioning, you can use the infrared remote control to emit the light to your equipment and automate your air conditioning. And so I like robots very much. I did this other one. What is it? I'm looking to the here it. I have this other one. I'm using Java, and this is the Intel Galileo. So I am in the robot test phase with Intel Galileo. I like this chassis. I talked in our robot hangout that you can watch on the YouTube channel also. And I like this chassis because it's very easy to mount, very strong, very fast, and you can make line followers with a very good precision. And I'm just using Galileo here, and I have a Arduino Shield because Galileo is it is Arduino compatible. Actually, it has a virtual Arduino. It's not a physical microcontroller. So it virtualizes the Arduino inside, which is not that good, not yet, I think. But I was trying, and I am dealing with some issues to make the communication with the Arduino and the Linux and the Java, etc. So I need to spend more time here. But as you see, I like to build robots with the sample boards. And here we have this panel. I'm using the chalkboard screen. This is type of iPad. Let me see if I am in the right place. Yeah, I am in the right place. This is iPad touchscreen interface. If you look in the back of this panel, we have here a Raspberry Pi connected to that using this board here. This board that just make the HDMI connection. Oops, let me see here. It's not easy to be a cameraman using a laptop. Here we go. So this is the board, the chalk board that connects the screen interface, and it also has a USB cable for the touch commands. And here we also have a camera attached to this panel. And we also have a Makey keyboard. The Makey, you can build your own keyboard using conductive and resistance. So I can put the alligator clips like in the water, and once I touch the ground at the same time that I touch the water will be uh, uh, any key of your keyboard, like arrow keys, space, return, and right click, left click from the mouse. So the Makey is a very nice way to make different keyboards. And the idea of this is we have a Java FX application running in this panel, and we intend to use this panel in conference so the people can take group self pictures in group. So the idea is the people will need to give the hands or to hug each other, having a skin contact, and one will touch the ground and another one will touch something, and this it will close the circuit, and it will activate the Raspberry Pi camera, and it will take a picture and send to a social network. And so this is a funny project. Just the JavaFX code is very simple, and the just having ideas with existent resources that I have in my hand. And this guy here is the Udo board. This is a pretty new board with it's 4 times faster, more powerful than Raspberry Pi, with wireless, Bluetooth, uh, SATA connection for hard disks, HDMI, Ethernet, USB. You have, uh, and you also have an Arduino DUI inside the board. So you can have the best of both worlds, like you can have the dedicated microcontroller just to drive the GPIOs, I2C, SPI, things like that. And also you can have the power of the Linux running inside a computer that is 4 times faster than the Raspberry Pi. So if you want to check for more information, udoo.org. And udoo.org, double O. And here we have another panel. This panel we are using a lot in the last year. So we have different boards, Raspberry Pi, Gmount concept board that we produce a video about. This board is very nice. Big open black, Mino board. So you can run Java in all those kinds of boards, make your GPIO connections, start reading your sensors, and you can use actually any of those boards to make your project for the contest. Let me just press start because I prepare a demonstration here, but just notice that the wireless module was not on. And if it starts happening with you, you are using Raspberry Pi, and the wireless just turn off, check your power supply. Sometimes you don't have a power supply to give current enough to have the wireless module running. So just let me check here. I'm going to show you something, and it's the last one. Just let me see if I have, yeah, this is right, and okay, he's back again. So what I'm going to do now is to make a connection with my panel, the embedded panel, to make this demonstration for you today. And just let me share my screen with you. Share my screen, full screen, right. Okay, so now I'm going to start a PuTTY session with this IP address, which is the embedded panel. And log on as Pi Raspberry. Okay. And I'm going to start, which is my server for exposing all the boards and sensors through the REST calls. And now what we have here is once it started, we did a home automation concept based on Minecraft. So we produce, let's just check if it's working. Yeah, it's working, perfect. What we did is this virtual world, and we have these levers, it is called levers. And behind this guy, we have some Java code running on Raspberry Pi into a server inside Raspberry Pi that is to create modifications, mods for Minecraft. And so here, once I click in this lever, it will turn on a light inside my office. I will show you the light turning on and off, but I will not be able to show both things, the light and also the lever here, but trust me, it's working. And this lever, I can have the control of the Steve's head. So it's an interactive way, interactive project that connects the virtual world with the real world. And if I put my hand in the front of the robot, you will see some fireworks here. So take a look. I'm putting my hand in front of Steve, and so I'm having the fireworks again. And I can use the humidity sensor to make it rain inside the virtual world. So it's very nice to see that Minecraft is a fever, and it's all about Java. Minecraft is all done in Java. So it's a very nice implementation with a Java engine, and also behind the game, and also a Raspberry Pi server, a Java server running on Raspberry Pi, a Java modification plugin that integrate the home automation system with your Minecraft game, so you could replicate your house inside Minecraft. So let me return to the real world. Now let me show the things in the real world here. And okay, so I'm back. And so now what I'm going to do is I'm going to try to stay like this, and I'm going to the Minecraft, and I'm going to the levers. Let me walk here, and oops, no guy, bad boy. So here we go. Okay, so here we go. It's taking some time because I'm using the Wi-Fi module, and my machine is very overloaded here. So I'm turning on, and with some delay, we are turning on the lamps. Here we go. The lamps using Minecraft. So it's very, very fun, and it's very useful. It could be a product, actually. Let me show you Steve again, the details behind Steve. Steve is a complete robot with servos, articulation for his head, with articulation for his hand, and different types of sensor. It has also a camera in his eyes, and the camera, if you click in the wall, you can take pictures. And we used Steve to show the Java technology end-to-end implementation during the last Maker Fair this weekend. And so it was very, very crazy fair the last weekend, very fun. So here we have some projects, we have some ideas, some of my experiences migrating projects from Arduino to Raspberry Pi, some reasons why we are doing that. And we are available to answer your question at the Oracle Community Forum. I will remember again the address, so it's very easy to get there. Just go to the community at .oracle.com and go straight to the end of the page, and you will see Java Embedded. Here we go. Click here and go to the IoT Developer Challenge, and here we go. Just connect using Facebook, Twitter, and make your question here. We will be supporting your project. The deadline to submit your IoT Java project is next Thursday. So don't lose your time, and you just have like 7 days to finish your project. Remember that another important thing is that I am here to help you. I have time tomorrow, I have time Sunday, I have time Monday. I know that it will be a holiday in US, and if you need my support, it's not a volunteer. Actually, I am doing my job since Oracle just contract Global Code to help to promote. So I will be very happy to help your project and see your IoT implementation with Java. Even it is a very simple thing, like with relay, using some sensor. Just submit, because you will have your name in our list. You will have your project in our project list at our website. It will be good for you, and will be good for us to see different ideas and different projects on this challenge. So thanks a lot, and see you in the next hangout. Okay. Thanks for watching us live, and thanks for you that will be watching us offline after the hours here. Okay, so thank you so much, Java community. See you there. My Twitter is @vsenger, SENGER, VSENGER, and my email is vinicius@globalcode.com.br. But if you have any kind of technical question or need the support, we are trying to make all the support at the Oracle Java Community Forum. Okay, so thanks again, and have a good night or good day. Bye bye.